We can look at a bond from two perspectives. On one side is the investor. The investor buys the bond with the hope that it generates a good return for them. On the other side is the business. The business sells the bond to raise funds and must pay a cost in the form of interest. The rate of return the investor receives is the flip side of the cost the borrower pays. Two sides of the same coin. Determining the rate of return on a bond is important for both the investor and the borrower. For the investor, knowing the rate of return can allow them to compare against other potential investment opportunities, and for the borrower, it's important to know how much you're paying to raise capital. So in this video, we're going to discuss the methods used to determine the rate of return on a bond. The rate of return on a bond can be represented by its yield to maturity. If you bought a bond today and held on to it all the way to the maturity date, the yield to maturity would be the average annual rate of return you'd receive. And from a company's perspective, it's the average annual cost you would pay to borrow money. The yield to maturity is an implied rate of return, meaning that it's an interest rate that simply links the current price to the future cash flows. For example, if you buy a bond for $1,000 and expect to get cash flows of $60, $60, and then $60 plus $1,000 over the next 3 years, what's your implied rate of return? This concept should sound familiar to you. To find the yield to maturity on a bond, we're simply going to be solving for the interest rate in a time value money problem. One thing you should keep in your mind is that the yield to maturity is, by definition, an APR. It's an average annual rate of return. So you need to be a little careful with the time units when trying to find the yield to maturity. You'll see what I mean by that with this example. In this example here, we're going to find a bond's yield to maturity. Say we have a semi-annual coupon bond with a face value of $1,000 and a coupon rate of 7%. And this bond matures in 5 years. If the price is currently $980, what is its yield to maturity? Since we're solving for I in the time value money problem, I'll set up an input table like I usually do. Since this is a semi-annual coupon bond, we'll be getting an interest payment twice a year over the 5 years. So N will be 5 years times 2, 10 semi-annual periods. The present value represents what cash flow is occurring today at time 0 on the timeline. Well, today we would have to pay $980 today to buy the bond. That's a cash outflow, so we'll make PV equal to negative $980. In return for paying $980 today, we'll receive $1,000 at the maturity date, so FV will be positive $1,000. And we'll also receive $35 every semi-annual period. That's $70 annual coupon payment divided into 2 pieces. Solving for I, we get 3.74%. Now, what are the time units on this I? This is 3.74% per semi-annual period. Remember, the time units are consistent. So if you have a semi-annual N and a semi-annual payment, then the I you solve for will also be in terms of semi-annual units. Now, recall what I said a little bit earlier about the yield to maturity. It's by definition an APR. It represents an average annual rate of return. Since we want to know the yield to maturity here, we need to convert that 3.74% semi-annual rate into an annual rate. This turns out to be a really simple conversion. We'll just take the semi-annual rate and multiply it by 2. That gives us 7.48%. This is our yield to maturity for this bond. If we buy the bond today and hold it for the entire 5 years, we can expect an average return of 7.48% per year. Let's do another example to make sure we really understand this concept. Let's work with a 6% annual coupon bond with a face value of $1,000 that matures in 12 years. The current value of this bond is $1,100, and we want to find its yield to maturity. Our input table will look like this. We'll have 12 years into maturity. Notice that this is an annual coupon bond, so our units need to be in terms of years. So N is going to be 12 years. The PV is going to be negative $1,100 since we have to pay $1,100 today in order to receive $1,000 at the maturity date. That's going to be a face value or FV of $1,000 and a PMT of $60 per year. Solving for I, we get 4.87% per year. Because yield to maturity is an APR, we don't need to do any conversions. The 4.87% is our yield to maturity. It's an annual rate. What I want to do now is break down the yield to maturity a little bit. Since yield to maturity is a rate of return, I might want to know what aspects of the bond's performance is driving the return I receive. Imagine buying a security like a bond. How can you make money or get a return off the investment? Well, there are only two ways to make money. There are only two ways to get a return on a bond investment. The first is by receiving income. Every time the bond makes a coupon payment, you get some money. So that income is part of your return on investment. The second way to make money on a bond investment is the value of the bond changes over time. If you bought the bond for $900 and it's now worth $1,000, you've made $100. That change in price is called the capital gain or capital loss if we have a decrease in value. That capital gain will also be a part of your return on investment. So we can decompose the total average return on a bond, the yield to maturity, into two parts corresponding to these two different ways to make money. The first component is called the current yield. This is the part of the yield to maturity that's driven by the interest payments that are received. And we can compute the current yield by taking the annual coupon payment and dividing it by the bond's current price. The second component is the capital gains yield. This is the portion of the yield to maturity that's driven by the bond's value changing over time. The capital gains yield will be computed as the expected change in the bond's value over the year. And the formula to solve this is just a simple percent change formula. We'll take the bond's estimated value next year at year 1 minus the bond's current value at year 0 and divide all that by the bond's current value. This will tell us how much the bond's value increased or decreased in percentage terms. Putting those two components of the return together, the current yield and the capital gains yield, will give us the bond's total return, its yield to maturity. Let's do an example. We have XYZ Corp, and they have 7% annual coupon bonds with 8 years until maturity that are currently selling for $845. We first want to know this bond's yield to maturity. We can solve for the I of this bond, and that's going to give us the implied rate of return on it. N is 8 yearly payments, since this is an annual coupon bond, and we pay $845, the present value, in order to receive $1,000, the future value, and coupon payments of $70 per year, which is going to be the PMT. Solving for I, we get a yield to maturity of 9.89% per year. So that's going to be our APR, our yield to maturity. Now let's decompose that yield to maturity into parts and see how much of the return is coming from the interest it pays and how much is coming from the expected change in price. We can find the current yield first. We can get the current yield by taking the annual coupon payment, which is $70 per year, and dividing it by the bond's current value, which is $845. Doing that, we get 8.28%. Of the bond's 9.89% total yield to maturity, 8.28 of that is coming from the interest payments that we receive. Next, we need to find how much of the yield to maturity is coming from the capital gains yield. The capital gains yield is defined as the expected percent change in price over the year, as we see in the formula here. But we're left with a problem. We know what the bond's value is today. It's worth $845, but we don't know the value next year. The good news is we can estimate it. If today there are 8 years into maturity, what will it be next year? Well, next year there's just going to be 7 years to maturity. 1 year has gone by. So N will be 7 years. For I, we'll put in the yield to maturity that we found earlier, that 9.89%. By doing this, we're making an assumption. We're assuming that the economic conditions of this bond will not change between this year and next year. That is, the overall economy remains the same, the company is going to remain the same, etc. The future value and payment will stay at $1,000 and $70 per year, respectively, and we'll solve for the PV. And then we find the estimated value next year will increase to $858. Note that this is consistent with what we learned about the relationship between bond values in time. As we move closer to the maturity date, the bond's value will converge towards the face value. Now that we have an estimated value for the bond next year, we can compute the formula. We'll take the value next year minus the current value and divide that by the current value. And we get 1.61%. That's going to be our capital gains yield. We expect the price of this bond to increase by 1.61% over the next year. So out of the 9.89% total yield to maturity on this bond, 1.61 of that is coming from capital gains. You'll notice that if we sum the two components together, the current yield of 8.28% plus the capital gains yield of 1.61% is going to equal the yield to maturity of 9.89%. This occurs because we just broke up the total return of this bond into its separate components. The yield to maturity is a key piece of information for both the investor and the firm. Knowing what type of return you're going to receive as an investor, or knowing the cost that you're paying for funds as a business, is vital in order to make proper decisions, as we're going to see in future chapters.